You might be asking, why are you doing all these transformations? Um, I have a test on this. Again, yes. So take advantage here to review this. So let's take this. Let's do some translations, reflections, rotations. Shouldn't take long. We're moving this guy 5 to the right and 7 up. So that's pretty easy, right? So take 1 point and move each point, or um, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So there's K prime. Now L prime repeats the same process. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. L prime. I'm going to take a shortcut. This is M prime. Notice that point J here is right here as well. So this was a translation, which is a rigid transformation. It kept the same size, same shape, right? Nothing else changed. Again, 1 to the right and 1 up. So 1 to the right, 1 up. Here's S prime. 1 to the right, 1 up. Here's T prime. 1 to the right, 1 up. Here's U prime. Pretty easy. You might be asked for points. 2 down. Okay, so seriously? 2 down, so Q, 1, 2. Here's Q prime. P prime is 1 unit away, so we can just graph it. 1, 2. Here's R prime, and here's S prime. Pretty simple. That's translations. 2 left and 6 down. 1, 2, 1, 2, 3, 4, 5, 6. Here's K prime. 1, 2, 1, 2, 3, 4, 5, 6. Here's M prime. And L prime will be actually just here. Reflections. Remember with reflection, I want you to take a moment and highlight your line of reflection so that you don't get confused. So we're, oops, and I just did that. So we're actually reflecting over the y-axis. Here's my line of reflection. So if you're on the left side, guess what? Your image is going to be on that side. If you're on the right side, your image is going to be on the left side. Not a big deal. So just count the distance you are from the line of reflection. So look at point G is 1, 2, 3 units away. So its reflection will be 1, 2, 3 on the other side. And there's G prime. F is 2 units away from the line of reflection. So on the other side, there's F prime. E prime is right under it. Where's H prime? H prime would be on the other side to the left. Let's connect the dots. Same shape, same size, just reflect it. We're going to reflect this over the y-axis again. Okay. So we have 4 points. Actually, there's billions and billions of points, but we chose 4 points. We're going to reflect it on the other side. Every point must be equally distanced from the line reflection. So point L prime is here. Point M prime is going to be here. Point J is going to be 1, 2, or 1, 2 on the other side. Point K is 1, 2, 3, 4, 5, and it's going to be on the other side. 1, 2, 3, 4, 5. Here's point K. Connect, 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 connect. Same shape, same size, just reflected on the other side. We're going to skip these 2, 7 and 8, because we did not go through these. 7 and 8 I don't want you to do, sadly. Did we do it? You know what? I'm going to do it. So the line y equals negative x, right? So there's 3 types of reflections that we're going to work with. Reflect over this. So if you have a point here, your reflection would be over here. If you have a line reflection vertical, or if you're here, then your image is over here. The line y equals negative x is this line right here that goes through the center. And that's our line of reflection. So Where would this be on the other side? Well, point T is on the line, so T prime, let me change colors, it's still on the line, it's the exact same spot. Now, instead of count, so when we reflect something, like for example, here, we count 1, 2, 2 units away, and its reflection would be 2 units away. But S, to figure out where S is on this diagonal line, we gotta go through we gotta count diagonals. Watch, 1, 2. That's the distance that we have to measure. And notice that it's diagonal. So on the other side, we're gonna go through the diagonals. So the diagonal of each box. So diagonal of one box, diagonal of another box. So if you remember it, that would be S prime. U is 1 diagonal, 2 diagonals, and a half. So 2 and a half. On the other side, let's count half, 1, 2. And this is U prime. If you connect, it's going to look like little angel wings. And you can tell that it's correctly reflected because when you fold this paper, all one wing would be right on top of the other wing. Okay. Now, that's why y equals negative x. Y equals x would be the other diagonal. There. Going through the center. Remember slope? This is a line that is proportional and it goes through the origin, right? So let's see how we reflect this. Where would be point F? Point F would be right here. F prime. Where would be I prime? Again, we count diagonals. So it would be 1 diagonal, 2 diagonals, so 2 diagonal on the other side, like this, and there's point I prime. G would be G. Oh my God. G and H just switch spots, so G prime would be over here, and H prime would be over here. So let's see if I do it correctly. And again, you can see that it's the same shape, same side, just reflected over this line. Let me put an arrow. Forgot. Then we have these two at the bottom. Remember rotations, we have to consider the direction, so we have clockwise and counterclockwise. Every 90 degrees, remember what we said in class, every point travels 1 quadrant over for every 90 degrees. So if we're talking about, let me label the quadrants, 1, 2, 3, 4. So this is traveling counterclockwise, which is this direction. So everybody here, point T, point U, point V, will travel 1 quadrant over. So they're in quadrant 4, so T is going to go from here to somewhere over here. U is going to go from quadrant 4 to quadrant 1. And U is going to go from this axis to this axis. That's how they're going to travel. Let's be more precise. Let's take point T. Point T, and I'll write it over here. Point T is 1, comma, negative 4. 1, 2, 3, 4. Yeah. So T prime, remember what we do? We switch the positions. 1 goes this way, and 4 goes this way, right? So they switch positions. It becomes 4 and 1. And remember, after you switch positions, you worry about their signs. Because T is going to land in quadrant 1, it's going to be positive, positive. So 1, 2, 3, 4, and 1. Here's T prime. Point U is on 3 and 0. It's going to switch spots, and U prime is going to be on 0, 3. So 0 and 1, 2, 3. Point V, let's see where point V is. Point V is currently at 5, negative 1. Switch spots, 5 and 1 switch places. And it lands in quadrant 1, and in quadrant 1 both numbers are positive, so it's going to be 1 and 5 right here. That's V prime. So connect, connect, connect. Yeah. This one is a 100 degrees, 180 degree rotation, so it just means that it's going to look something like this, right? The only difference between this problem and the previous problem is that every point will travel 2 quadrants over. Okay, so point C, here's my quadrants. Let's start with point C. Point C is at -2 and comma 4. So it's going to switch the positions. So C prime, so -2 and 4, remember, here's -2 and 4. It becomes 4 and 2, and then switch again, it becomes 2 and 4. So let's write that C prime is 2 and 4, and it goes from 1, jumps 1 quadrant, and jumps another quadrant. So point C lands in quadrant 4, and in quadrant 4, the y is negative. So it's 2, -4. So here's point C. Point B, point B is at -3, -1, switch positions, becomes 1, 3, switch positions again. And B prime is going to be, well, B is going to go from quadrant 3 to quadrant 2 to quadrant 1. In quadrant 1, everybody's positive, so the actual points are 3 and 1. So B prime is at 1, 2, 3. Here's B prime. And D, well, D is going to stay on the axis, so it's going to go one axis, another axis. There's D prime. Connect, and look at that. Rotation clockwise, so this triangle is moving this direction. Okay, so everybody, C is going to go here, D is going to go here, and E is going to land here. Everybody travels 1 quadrant over. Let's be more precise. So E, let's start with E. E is at 3, comma, -4. It's going to go from here to E prime. We're going to switch positions. It becomes 4 and 3. And E is going to go from here to quadrant 3. And in quadrant 3, everybody's negative. So now it becomes -4, -3. Right? C prime. C currently is at -1, -3. And it's going to go, they switch positions, so it becomes 3 and 1. But it lands in quadrant 2, and in quadrant 2, first number is positive, so it becomes -3, comma 1. There we go, and there's C prime. Point D. Point D, currently it's at 1, -2. It's going to go 1 quadrant over. It's going to switch the numbers. It's going to go from quadrant 4 back to quadrant 3, and deep in quadrant 3, everybody is negative. -2. And there is your triangle. Rotated clockwise 90 degrees. So this triangle is going to look something like this. So everybody is in quadrant 1, and after a 180 degree rotation, right, everybody in that triangle is going to shift 1 quadrant, 2 quadrants. So everybody's going to be in quadrant 3. So that makes life easier. So for point U, which is 2, 4, it's going to switch to 4, 2, and it's going to switch back to 2, 4. So U prime is going to be, well, everybody's going to be negative because quadrant 3 is negative. So this becomes -2, -2, -2, -4. So there's U prime. Point T is easy. Is it 1, 1 right now? If you switch, it's just going to be 1, 1, but it's going to be in quadrant 3, so negative. So here's point T prime. Point V is at 5. Point V is at 5, comma 5. It switches again. Doesn't matter because it's still 5 and 5, but everybody's going to be negative, so -5, -5. So right here. Let me connect. And there you are. Okay, and this is V prime. That's it. That should be okay for you to read.